A point. Our universe may be located inside a black hole. This concept has been circulating over the past few years, but was recently brought up again as a result of the study conducted by Dr. Charles Lineweaver and his student Vihana Patel. Despite immense opposition from the scientific community, the study passed through the sieve and it was published in the American Journal of Physics. Lineweaver's findings are quite significant, and thanks to the use of the logarithmic diagram, he pointed to areas that defy known laws of physics, extending into the realm of quantum mechanics. Ideas like this have been recurring over the last decades. Scientists have noted, among other things, that in the first 1 billionth of a second after the Big Bang, the universe began to expand at a speed faster than the speed of light. What does it mean that until that time space did not exist, so there was no universal speed limit? Thus, one can logically infer that the expansion of space slows down over time. Einstein's theory of relativity states, however, that massive objects warp spacetime. Therefore, the space around the black hole is clearly curved. Truth be told, spotting a black hole would be physically impossible, if not for the fact they say the material absorbed by them is accelerated to incredible speeds, generating light and heat. The more matter a black hole absorbs, the larger it becomes, as does its event horizon. Our cosmos contains three-dimensional black holes with two-dimensional event horizons. The useful theory analyzed thus that there might also exist four-dimensional black holes, and we allows us to inhabit a three-dimensional event horizon of one of such giants. That's what was suggested years ago. Meanwhile, Lineweaver and Patel provided direct data suggesting our universe might be a colossal black hole. Separating areas marked by them as forbidden by gravity from the space occupied by objects known to us. In the bold line are black holes, whose density decreases as their mass increases. Although the left side of this line remains theoretical, astronomers have observed black holes of various sizes, from remnants of collapsing stars to supermassive giants. This pattern is well established and understood. Lineweaver notes, however, that the lines spotted there resemble an event horizon, which in one way or another encompasses the universe we observe. It's worth mentioning that the researchers used only data obtained from the Hubble telescope. So it's possible that future observations made using the James Webb telescope could allow for even more precise determination. If this hypothesis turned out to be true, it would mean that the current configuration of the universe might not be a matter of chance, or rather complex multi-dimensional processes that we are not even able to observe. We live in such interesting times that we might get an answer to that question in our lifetime. It's worth mentioning that one of the first proponents of this theory was the Polish physicist Nikodem Popławski, who worked at Indiana University. His concept assumed that our entire universe is inside a gigantic black hole, which in turn is in another supermassive universe. He presented his theorems back in 2013, not gaining much sympathy from the scientific community in the process. Adopting such a hypothesis, however, helps explain some contradictions present in the current universe theory. In the model of the universe developed by the American physicist, black holes occupy one of the fundamental positions. Popławski suggested that these are entrances to hypothetical Einstein-Rosen tunnels, or wormholes, which connects different places in a four-dimensional space-time. In this model, a black hole is a tunnel connected to its opposite, a white hole, which is located at the other end of the subspace tunnel. However, this doesn't give us the ability to travel across the universe because, according to Popławski, our entire universe is hidden inside a tunnel connecting a black and white hole. This model of the universe, it is supposed to help in explaining the most difficult problems in modern cosmology, such as dark matter or dark energy. Some researchers are now attributing them to supermassive black holes. The scientist argues that in such a system, space-time should twist. But detecting this fact can be very challenging, especially if we are part of that measurement. Accepting this model of the universe implies that every hole in our universe might be a gateway to another world. However, it's not clear how many such universes might exist, and Popovsky himself noted that there's always the question of some primeval universe. Where it is located, it's easy to get caught up in this hypothesis, and the dilemma will always resemble the famous which came first, the chicken or the egg. Nikodem Popovsky notes that in our universe, all black holes, stars, and celestial bodies have their specific spin. From a logical point of view, it should be the same in a supergiant universe, where there is a black hole with our universe in it. The fact also somewhat provides evidence in support of this hypothesis. As the scientist himself noted, in one part of our universe, spiral galaxies turn to the left, while in the other to the right. This is supposedly evidence supporting the hypothesis of the twisting of space-time inside the singularity between a black and white hole. Of course, we should not forget that after more than 10 years, science is already able. She didn't push the theory too far forward. A study published by Charles Lineweaver proves, however, that there are some very interesting aspects to our reality and more new discoveries. They might give us a better look at the mysteries lurking in our universe. The question of whether the entire observable universe is inside a black hole remains unanswered for now, but without a doubt requires further thought and research. Perhaps creating a complete map of the observable universe would give us more room to maneuver. Scientists primarily operate on a small segment, performed through the Hubble telescope. What should be most important from our perspective is that new research avenues are joyfully embraced by the scientific community. What are your thoughts on this matter? If it turned out we all live inside a black hole, would it somehow change your perception of the world? Did it not have even the slightest impact on your lives? Feel free to share such considerations below in the comments section. Feel free to subscribe to the channel, hit the bell, support our activities, and of course, I hope we'll hear from each other very soon.